Hey guys, welcome back to day 2 of 100 Days of Code. In today's lessons, you're going to be learning about data types, numbers, operations, type conversion, F strings, and a whole lot more. And by the end of today, you will have learned enough to build a tip calculator. So it looks a bit like this. It says, welcome to the tip calculator. It asks you for the total bill that you need to pay. So let's say it came to $124.54. We hit enter, and then it asks you how many people do you want to split the bill between. So let's say there's 5 of us having the meal, and it asks you finally, what percentage tip would you like to give? So let's say we give a 12% tip. Now it's going to calculate what each person should pay, taking into account all of these pieces of information that you've put in. So I know that I'm pretty bad at maths, especially when it comes to splitting bills, and I'm normally the person who just says, yeah, just tell me what I need to pay so I don't have to calculate it. It's like the bad at maths tax that I pay. But in order to build this, you're going to need to learn some new skills, including working with numbers, converting data types from one type to another, and a whole lot more. So if you feel like you can tackle this no problems, then feel free to skip today's lessons. But I bet that there'll be loads of stuff that you'll come across in the upcoming lessons and coding exercises that's really going to make you a better developer. So once you're ready to get started, head over to the next lesson and let's start coding. Yesterday, you saw that we could use the len function to get the number of characters in a string. So for example, when I write len hello and I print this out, we end up with 5. There's 5 characters in the string hello. Now, here's a question. What happens if instead of counting the number of characters in a string, what if I put in a number instead? And I wanted to know how many digits are in this number. Now, if I go ahead and run this code, you'll see that it actually crashes. I get a whole bunch of red text and it tells me that there is a type error and something about the type int. So what is all of this about? Well, in order to understand it, we first have to learn about data types. Now, on day 1, we already explored this data type called strings. Now, you're probably not going to be surprised to learn that there's a whole lot more other data types out there. And today, we're going to explore some of the most important and some of the most basic data types, such as strings, integers, floats, and booleans. And we'll explore each of these in detail. So go ahead and get hold of the Day 2 Start Coding Sandbox and go ahead and fork your own copy of it. Now, once you've done that, let's take a look at some of the data types. So we already learned about strings, right? And we know that this is just a string of characters. So the word hello is comprised of these 5 characters strung together. And we always know that strings, when we create them, we have to create them with these double quotes around. Now, because this is a string of characters, we can actually pull out each character individually. So we could, for example, instead of just writing hello, we can add some square brackets. So take a look on your keyboard and see where those are. And inside the square brackets, we can put the index or the position of the character that we want. So for example, if I wanted to have the first character out of this word hello, I would put 0 right here. And if I go ahead and print what this actually will give me, you'll see that you get capital H because that is the first character of this string. And it's really important to remember that programmers always start counting from 0 because we work with binary, zeros and ones. So whenever you want to get hold of the first character or the first of anything, it always is at 0. So this method of pulling out a particular element from a string is called subscripting. And the number in between the square brackets determines which character you're going to pull out. And it just goes up from 0 to 1 to 2 and so on and so forth. So whenever you get a result that's just off by 1, then remember to check whether if you've started counting from 0 or if you started counting from 1. Now, you can of course extend this and get hold of the last character. So pause the video and see if you can change the code so that O gets printed out here. Alright, so this is as simple as simply counting from 0, 1, 2, 3, 4. So if we change this to 4 and we run our code, then you'll see that O gets printed instead of the H. So by using these square brackets and putting a number inside, we're able to dissect our string and pull out individual characters as and when we need it. And this will come in really handy in a lot of the programs that you'll write in the future. Now, it's important to remember though that just because I can write a number like 1, 2, 3, as long as it's capped inside these double quotes, then this is not treated as a number by the computer. It's treated just as any other piece of text. You can't, for example, say, what is 1, 2, 3 plus 3, 4, 5? If I try to print this, what do you think will happen? Do you think it will give me 1, 2, 3 plus 3, 4, 5 in the traditional sense, like calculating it? Or do you think it'll do something else? All right, let's hit run. And we get 1, 2, 3, 3, 4, 5. So it's basically just concatenated these two strings together, just as we have done with other strings like hello and world, right? Because it sees the data type of these two pieces of data as strings, when we use the plus sign, it will actually just concatenate these two things instead of doing a mathematical operation. Now, if we wanted to do that, then we actually have to declare our number as a number data type. So one of the most common that you'll see is called an integer. So this is programming lingo for just whole numbers, numbers without any decimal places. And in order to create an integer or declare an integer data type, all you have to do is just write the number without anything else. So now, if I just write the numbers 1, 2, 3 plus 3, 4, 5, and then I go ahead and print this, then you'll see that we actually get 4, 6, 8. So it's actually being calculated because I've got actual numbers instead of strings. Just as we have some useful things that we can do with strings, there's some really handy things that you can do with integers. Commonly, when we write large numbers, at least in the UK or in the US, we like to put commas in between the thousands. So when we think of large numbers with these commas in between to split it into an easier to understand number, in Python, we can replace those commas simply with underscores, and it will be interpreted by the computer as if you had written this. So the computer actually removes those underscores and ignores it. The benefit is just for us humans to be able to visualize it more easily. So I mentioned that all whole numbers, no matter if they're positive or negative, are called integers in programming. So what do you call it when you actually have decimal places? Well, they're called a float. And this is short for a floating point number. So for example, if you had the numbers of pi, you have 3.14159. And this, because it has a decimal place, is now a float data type. So if you think of the decimal point as being able to float around the number because it could occur at any point, then you've got yourself a floating point number. Now, the final data type is something called a Boolean. And this is very simple. It only has two possible values, true or false. Now, note how these values always begin with a capital T or a capital F, and they don't have any quotation marks around them or anything. So this is actually a data type which is going to be used a lot in your programs to test if something is true or if something is false, and for your program to respond accordingly. So we're going to be using this a lot more in the future. Now that you've seen a lot of the basic data types, strings, integers, floats, and Boolean, I want you to head over to the next lesson where I've got a quiz for you to see if you've made this knowledge your own. So head over to the quiz and give it a go. Previously, we saw how the len function gives us a type error when we give it a number instead of a string. So let's talk a little bit more about data types and functions. And the way I think about functions is kind of like some sort of fancy machine that you might see in a factory, right? So in this case, we've got some sort of machine that's going to take potatoes into chips. And we don't really care how it does it, but it's probably going to have to peel the potatoes, wash the potatoes, cut it up, fry it, and then finally return it to us as an output in the form of fries. And if this is the first time that you're watching one of my tutorials, this is probably a health warning. I talk about food a lot. So be prepared if you haven't eaten. Now, let's say that we took the same machine that normally processes potatoes and we decide to give it a rock. And we just pass this through the function. Then we're going to get an error, right? This is basically what happened here. This length function doesn't like working with integers. And by forcing this through, we end up with an error and our code breaks. And it gives us this thing, a type error. Now, do you remember previously we had this challenge where we asked you to get an input from the user? What is your name? And then we use the length function to get the number of characters of their name. And let's just save that to a variable. Let's call it numchar equals this. And then we print your name has plus number of characters plus characters. So in this case, you would expect it to prompt the user to enter their name. Let's say I enter my name, Angela, and the length of that string would be 6. So this would be equal to 6. And so this would get substituted in here. And then with string concatenation, we end up printing your name has 6 characters. But this is not what happens. And I know that some of you might have tried this for the previous challenge and you would have gotten a type error. So it tells you that you can only concatenate strings, not integers. So in this case, where we're concatenating a string to an integer, this is what we get. We end up with an error. So how can we prevent these type errors? And how can we see the data type that we're working with? Well, we could use a function called type, which basically will check whatever you put between the parentheses and give you the type of data that it is. For example, if I go ahead and just comment out this line of code, which breaks, and go ahead and put numchar, so this particular piece of data, inside this type function, and then I'm going to print the type of numchar. And now if I hit run, let's enter my name, and you can see it's telling you that this is an integer. So adding a string to an integer doesn't make any sense, which is why you got the type error. Now, every so often when you're writing code and you're not quite sure what the type of data of something might be, then you can simply just put it inside a type check function, right? Like so. And then you'll get an answer. Now, in addition to type checking, we can also do type conversion, or you might hear it called type casting, where we change a piece of data from one particular data type to another. So for example, we know that this variable, numchar, has the data type of integer. If we wanted to turn it into a string so that this line of code wouldn't break anymore, then we could convert it into a string by writing str, and then inside the parentheses, we put in the variable that we want to convert, which is called numchar. And now we save this into a new variable. We'll call it new numchar. And once we've converted this into a string and stored it under this name, then we can use it inside our print statement, new numchar, and now it won't break anymore. And it tells us your name has 6 characters. So in this case, we've taken a integer data type, put it inside the parentheses of a str function, which takes a object in between the parentheses and converts it into a string. which we then store inside this new numchar, and we can now use it in our print statement because all the data types of all the pieces of data that we're adding together have the same data type, string. Now, you're not limited to only converting numbers into strings. You can convert a whole bunch of different data types. So let me go ahead and comment out this code, and I can show you that, let's say that we had a variable a, which we set to a number, right? 1, 2, 3. And if I do a type check on a and print this, you'll see that, as you would expect, it should give you integer, right? A is an integer. But now, let's say I converted a into a string by wrapping it inside the string function, then hit enter, you can see it's now of type string. Now, I can do this with other things as well. So, for example, I could turn my whole number here into a float. And when I run my code now, we see that the type of my variable is a float. And that's pretty straightforward, right? But let me ask you two quick questions before we wrap up. What will this line of code print? All right, you guessed it. This will print 170.5. But what's actually happening behind the scenes is we're converting this string 100.5 into a floating point number. And then we're adding 70 to 100.5, and finally we're printing the result. But what about this line? What will print here? Have a guess. Well, this time we get 70100. So in summary, you can use the type function to investigate the data type you're working with. And you can use functions like string, int, or float to convert to that data type. In the next lesson, I've got a coding challenge for you. So head over there and we'll get started. All right, now it's time to put what you've learned into practice by clicking on the Data Types Day 2.1 Code Challenge. In this challenge, the idea is that you're going to be given a random 2-digit number, so something like 39, and your code that you'll write will be able to add the first digit to the second digit and end up with a numerical result. So, for example, if the input was 39, then 3 plus 9 would be equal to 12, so the output would be 12. And if the input was 26, then your code needs to print 8 to the console. So you're going to need to think about type checking, type conversion, as well as everything that you've learned before. And then you're going to write your code below this line without changing any of these lines. So pause the video now and give this code challenge a go. All right, so how did that go? Did you manage to do it? If not, have a cup of tea or give yourself a little bit of a break, think about something else, and then come back to it and try it again. If you've already given it a good go and you want to see what the solution might be, then follow along with me. So the first thing we know is that we're going to have a variable that's going to be equal to a 2-digit number. But remember that that could mean anything. That could mean an integer, that could mean a floating point number, that could even mean a number as a string. So it might be helpful to actually find out the data type of this 2-digit number that we get. And to do that, we of course use the type function, all lowercase, and then in between the parentheses, we add the thing that we want to check. So it's this variable. And then let's go ahead and print the result into the console. So now let's run our code and let's type a 2-digit number, say 56, and we get the result that the type of this 2-digit number is a string. Because of course, we're getting hold of this through the input function. And the user could be typing anything into this input, a string, their name, or a number. So now that we know that this variable has the data type string, then we can think a little bit about what we know we can do with strings. We can subscript strings, right? So if we had a string like hello, and we wanted to get hold of the first character, we could put 0 there, and when I print this, we'll get H being selected out of this string. So if we know that we can subscript strings to get hold of a particular value at a particular position just by using subscripting like this, then we can do the same with our two-digit number. So we could say two-digit number, let's get hold of the first digit. So let's call it first digit equals two-digit number, square brackets 0. And then the second digit could be two-digit number, square brackets 1. Now, when I go ahead and print these two items, first digit and second digit, then you'll see that if I enter a number like 87, then my first digit is 8 and my second digit is 7. So now I can probably start thinking about adding those two digits together. For example, we could say that result equals first digit plus second digit. But of course, when I run this right now and I print the value of result, you'll see that for a number like 87, what I will get is just 8 concatenated to 7, which turns it back into 87, which is not what I want at all, especially after all of my hard work separating out the digits. What I want to do instead is to turn each of these, which currently has the data type of string. So I can demonstrate that to you by saying type of first digit. You can see it is a string. So if I could only change first digit and second digit from string data types into an integer data type by using the type conversion that we learned about in the last lesson, well then, once I do that, then this plus sign has a whole different meaning, because now it's going to add this first digit to the second digit instead of concatenating it. So now if I go ahead and print the results, then you'll see that for the same number, 87, my result is now 15. I've now managed to achieve what the code exercise wants me to do. So did you manage to get it right? If not, go ahead and have a look at the model solution, and I've written some comments for each line of code that walks you through each of the steps. Now notice that instead of converting the second digit here, you can also do it up here, like what you see right here. So have a play around with the code, especially if you struggled with this and didn't manage to get it right. And then once you've understood what's going on here line by line, if you need, have a look at the previous videos, then go back to the code challenge and attempt it again. And only once you're happy that you really understand everything that was covered in this challenge, then head over to the next lesson where we're going to talk more about mathematical operators like the plus sign and others that you can use in your code. So for all of that and more, I'll see you on the next lesson. In the previous lesson, we saw how we could use the plus sign either to concatenate strings together or as a mathematical operation where we add two integers or two floats, basically two numbers together. In this lesson, I want to show you some of the other mathematical operators that you have access to, in addition to adding. The next obvious one is subtraction. So 7 minus 3, you would just use the minus sign. But then when you get to multiplication, it's a little bit weird. Instead of using the X or some sort of time symbol, you actually use the asterisk. So you would say something like 3 asterisk 2, and that would be 3 times 2. Now the final one is division, and that's done using the forward slash. So 6 divided by 3, and when that prints out, it'll give you 2. Now, one thing to notice here is that whenever you're dividing things, you actually always end up with a floating point number. So you can see even though 6 divides into 3 cleanly, we're still getting 2.0. And in fact, if I put a type check around this division, you'll see that it'll print float instead of integer. And this is just something that happens with division in Python. But at the end of the day, you get the result that you need, and it doesn't really matter whether if it's a float or if it's a integer. Now, the last one that's really useful is 2 asterisk signs. And this gives you access to the exponent, or when you want to raise a number to a power. So for example, if you wanted to get hold of 2 to the power of 2, then you would write it like this. And 2 to the power of 2 is, of course, basically just 2 times 2, which is going to be equal to 4. Now, if I change this to 2 to the power of 3, then that's going to be 2 times 2 times 2. So that should be 8, and so on and so forth. Having the exponent being built into the language is one of the reasons why Python is really loved by a lot of data scientists and mathematicians, because it's really optimized towards manipulating and handling numbers. Now, one of the things that you have to be careful about when you are doing these mathematical operations is when you have more than one operation on the same line of code, then there's a certain level of priority. So some of these operations, like division or multiplication, are going to be first class, whereas other ones are going to be more economy, like the plus and minus. And the rule that you might have remembered from high school is something called PEMDAS. It basically states the order of priority is parentheses, exponents, multiplication, division, addition, and subtraction. So the things that happen first are the things inside brackets. Then it's our exponents. Then it's our multiplication and division. And finally, the lowest priority is our addition and subtraction. Now, it's a little bit deceiving because of this order. It makes it seem like as if multiplication happens before division, but actually they are equally important. And when it actually comes to your calculations, the calculation that's most to the left is the one that will be prioritized between multiplication and division. So let me give you a real life example to make this more clear. Let's say we had a line of code where we wanted to multiply 3 by 3 plus 3 divided by 3 minus 3. If I was to execute this entire line of code and print it out into the console, here's the time where you play computer again and guess, using what you've learned here, what exactly will be printed. Because you will get a number printed. It will calculate this entire line of code for you, but the order matters. Is it going to first add 3 to 3, then multiply the result by 3? Or is it first going to divide 3 by 3 and then add 3 to it? What is the order? And I want you to really pause the video and have a little play with it on pen and paper before you come back and we'll show you the result. Using our rule PEMDAS, we can see the first thing that happens is what's in the parentheses, so that doesn't matter. The next thing are exponents. We don't actually have an exponent here. We don't have 2 to the power of 3 or something to the power of anything, so we can ignore that as well. So the next level is the multiplication and division. And as I mentioned, they are of equal importance. So this 3 times 3 and 3 divide 3 are both equally important, but the calculation goes from left to right. So the first thing we see is actually the multiplication. So if it helps you, you might want to add LR to the end of this mnemonic. So it becomes PEMDASLR, or at least that's the way I would think about it. So even if this was division and this was multiplication, this calculation will always get executed first. Coming back to the question I asked you, what do you think this number would be? Let's go ahead and comment out all the other code and run this line of code, and it will give us 7. Now, if math is not your strong point, don't worry, it's not mine either, and you're the sort of person who would prefer to see it visualized, then I recommend, again, putting this line of code in Thonny, and then go ahead and clicking on the debugging symbol, and then just step into, so press F7 or this button multiple times, and you'll see it evaluate this line of code step by step. So first it looks at the entire thing, and then it goes from left to right. And the first calculation is 3 times 3, and that is the one that's going to execute first, and it becomes 9. Next, it's going to look along this line of code and see that the next most important thing is this division here, 3 divided by 3. So it's going to carry out that next, and that becomes 1. So now 9 plus 1 is going to be the next thing because it's the most to the left, and then it becomes 10 minus 3, and we finally get the result of 7. So now here's another challenge for you. How can you change this code so that instead of getting 7, we get 3? How can you change this line of code given what you know about PEMDASLR? See if you can figure it out. Pause the video now. All right, so this will involve a little bit of trial and error. And the most important tool we have access to us is the parentheses or the brackets. This means that we can actually isolate bits of our code which normally have very low priority and turn them into higher priority operations. So in this case, we know that 3 times 3 is going to happen first, and then the multiplication, and then the addition on the left, and then the subtraction. But if we added a set of parentheses around our 3 plus 3, then out of all of these calculations, this particular one suddenly becomes the highest priority and it will happen first. So if I change what I've got in Thonny to our new version and go ahead and debug through it, the very first calculation it's going to perform is this 3 plus 3 inside the brackets. And we end up with 6. So then it's going to go again from left to right, prioritizing multiplication and division. So then it's 3 times 6 is 18. 18 divided by 3 is 6. 6 minus 3 is 3. Just by isolating certain calculations, you can elevate it to right at the top of the priority list, and you will be able to perform the calculations that you need. Now that you've learned a lot about calculations and performing mathematical operations using Python, I've got another code challenge for you. So head over to the next lesson and you'll be able to discover it there. All right, so in this code challenge, click on the day 2.2 BMI calculator code exercise. So the goal of the challenge is to be able to work out somebody's body mass index based on their weight and height that they input. So the body mass index is basically a way of measuring somebody's body composition that's kind of independent of their height, right? If 2 people are both 60 kilos, but one of them is tall and the other person is short, then the shorter guy is probably a little bit more overweight, right? So if you take a look at this chart here, let's say for me, my height is around 1.8 meters and about 60 something kilos. So I'm in this normal weight bracket of BMI, 18.5 to 25. So this is a really helpful tool for healthcare professionals to figure out whether if somebody is underweight, normal weight, or overweight, that is based on their height and weight. In our program, we're going to calculate this. So when we run our code, you can see it's asking us for an input, height in meters, so mine is 1.8, and my weight is, say, 63 kilos. And when I hit enter, ideally, I would like to get my BMI printed out as a whole number like this. So how can we achieve this? Well, firstly, you have to take a look at the equation that's used to calculate the BMI. It's somebody's weight in kilograms divided by their height squared. Then once you've got the result, we want it to be printed as a whole number or as an integer. So you'll have to think a little bit about type conversion. You'll have to think about the mathematical operations that we learned about in the last lesson and combine everything you've learned so far in order to solve this code challenge. So pause the video now and give that a go. All right, so now that you've had a go at it, I'm going to reveal the solution. In our code, we've already got access to the height and the weight as variables, so we can simply use them straight away. So for example, I could just print the height and it would be equal to whatever the user typed in when they were asked for it by the input. So in this case, my height would get printed out as 1.8. If we can access the height and weight, then we can calculate the BMI by simply replicating the mathematical equation here. So we know that the BMI is equal to the weight divided by the height squared. So we can take the weight and then we can use the / for divide, and then we can divide it by the height squared. So we're going to use the exponent operator to the power of 2. So this is how we could work out the BMI. But you'll see that if we actually run this code right now, we'll actually get an error. And what it's going to tell us is that on line 8, so right here where our equation is, there's a type error. And it's saying that you're trying to use the exponent or the power function for a string and an integer. So the 2 is the integer, but this is still a string. And we can confirm this if we check the type. So type of height, and let's comment that out. And let's print this. Then you'll see that when we enter some numbers here, the type of height and weight, in fact, is string because they came from the input function, which we saw in previous lessons. Before we can actually just simply run this equation and get the values we want, we had to convert all the strings into other data types, right? Now, the weight is probably okay as an integer or a whole number because it's already pretty accurate, 80 kilos or 85 kilos. We don't necessarily need any decimal places. But the height, on the other hand, definitely needs to be a floating point number because if it was an integer, then there would only be height of 1 meter, 2 meter, 3 meter, 4 meter. And because most people lie between 1 meter and 2 meter, then we really, really need those numbers after the decimal place in order to get an accurate calculation. So the height definitely needs to be a float. And we can convert it into a float using this line of code here, where we're converting this string into a float. And the weight, you can either convert it into an integer or a float, doesn't really matter. So now if we run our code again, you'll see we no longer have any errors and we're now able to print our BMI. Let me enter my height and weight again, and you can see I'm getting this BMI with a massive list of numbers afterwards. So in our result, we said it should be a whole number. How can we convert this BMI into a whole number? Well, we can turn it into BMI as integer and convert this floating point number, the BMI, with all of its numbers after the decimal place, into an integer, a whole number, which will just simply cut off everything that's after the decimal place. And now if we print this BMI as an integer, run our code, then you'll see that we get a whole number being printed out, which is now our BMI. In the next lesson, I'm actually going to show you how we can round these floating point numbers so that when it's 19.5 or above, it becomes 20. When it's 19.4 or 19.3, then it gets rounded down. But for now, this is all that we wanted. We wanted you to be able to cut off the end and turn it into a whole number. If you want to have a play around with the solution code, then head over to this Replit over here, and you'll be able to see the solution code with a lot of comments explaining the code line by line and showing you some different ways of doing things. For example, instead of converting the weight and height in line, on the line where we're actually doing the calculation, you could do it beforehand. Alternatively, instead of using the exponent operator, because something to the power of 2 is simply just something multiplied by itself, right? Then in this case, you could also just do height as a float times height as a float. Have a play around with this code and make sure that you're comfortable with everything that's here. And if you got anything wrong at all in the code challenge, then go back and fix it. Now, in the next lesson, we're going to be talking about more mathematical operators, such as rounding numbers instead of just cutting off the end. So for all of that and more, I'll see you on the next lesson.